Now we can continue using synthetic division and our remainder theorem in combination with the rational zeros theorem. Rational zeros theorem allows us to identify what the possible list of rational zeros of a polynomial function will be using what is colloquially referred to as p's over q's. If p is a factor of the constant term and q is a factor of the leading coefficient, we can use all of these factors in combination to find a list of possible rational zeros and use those to check to see what the actual zeros will be. So it's typically easiest if we just kind of dive right in and see what these p's over q's represent. So remember that p is the factors of the constant term. That's this term over here. And then q is the factors of the leading coefficient. So in order to generate our list of p's over q's, we're looking at 2 over 6. We do not want to simplify this fraction, but instead we're going to identify all the factors. So all the factors of 2 are 1 and 2, but also remember that we can multiply positives or negatives. For 6, all of our factors are 1, 2, 3, and 6. We're going to use this list to create all combinations of fractions that we can, matching every numerator with every denominator. For example, 1 over 1 equals positive and negative 1. 1 over 2 equals positive and negative 1/2. 1 over 3, positive and negative 1/3. And then 1 over 6 gives us positive and negative 1/6. Now we've finished that list with the ones. Now we need to do the same thing with the 2 as the numerator. 2 over 1 equals 2. 2 over 2 equals 1, which we already have, so we don't need to write it again. 2 over 3 is 2/3. And 2 over 6 is 1/3, which we already have, so we don't need to write it again. So my list of possible zeros is positive negative 1, positive negative 1/2, positive and negative 1/3, positive negative 1/6, positive negative 2, and then positive negative 2/3. So we have 12 possible rational zeros to choose from. If this function has rational zeros, they will be on this list. This list does not leave anything out, but these are not all the zeros. And what we need to do is now from this list, figure out what actually are the zeros. And there's a couple ways that we can do this. So the first thing we do is we kind of just guess and check to see what works. Remember, we can use our remainder theorem to determine if a zero is a zero of the polynomial, if a number is a zero of the polynomial, if we have a remainder of 0. So what we can do is just pick one of these numbers to do synthetic division with. And I'm just going to pick randomly a 1. So I pick 1, and I'm going to go ahead and set up synthetic division with the values that we have here. Since we got a remainder of 0, then that means that 1 is a 0. So we've identified one of our zeros. If we didn't get 1 as or 0 as a remainder, then all we would have to do is come back here and replace this with a different number and try again until we get a remainder of 0. There's also a little shortcut that we can use if you have a TI-84 graphing calculator. Let me pull that up and show you what we can do. So remember that zeros correspond to x-intercepts. So if we can look at the graph and identify where our x-intercepts are, it can make it a lot easier for us to validate using the remainder theorem. So we're going to go ahead and start by typing in the polynomial 6x to the 4th plus 7x to the 3rd minus 12x squared minus 3x plus 2, and then we're going to graph it. And if we look at our graph, and I'm going to zoom in a little bit just for us to see, it looks like we have an intercept at 1 over here. This is possibly 1/3. This looks like negative 1/2, and this looks like negative 2. So it looks like our best guesses to choose from are negative 2, negative 1/2, 1/3, and 1. And we just validated that 1 worked. So 1 is definitely one of our solutions. But we have these other options to choose from. If one of these didn't work, then we would just keep going and checking. We don't need to do synthetic division with all of these. We just need enough to get to a quadratic, so then we can factor or solve the quadratic that's left. Now, keep in mind, this quotient here is now 6x to the third plus 13x plus x minus 2. We don't have a quadratic yet, so we need to do synthetic division again with one of these numbers. So, since we already know that 1 worked, let's go ahead and try a different one like -2, and we can do synthetic division. If we get a remainder of 0, that means that -2 is a 0. If we don't, then we need to try a different number. We got a remainder of 0, so that means that -2 is a 0. So we just validated that as well. So now let's find the rest of them. So now what we have is 6x squared plus x minus 1. We need to try and factor this. So we want a product of -6 and a sum of 1. That's going to be a +3 and a -2. So 6x squared plus 3x minus 2x minus 1. We'll have 2x plus 1, 2x plus 1. So we're going to have factors of 3x minus 1 and 2x plus 1. We use our factor theorem, or zero factor theorem. This one. And so we can go ahead and solve, and we get x equals 1/3 and x equals -1/2, which again is validated by our guesses from up above. So we first have all of our zeros. We found that 1 was a 0 first, then -2, and then we solved for 1/3 and -1/2. So these are all 4 of our zeros. Now the problem also says to factor, so find all rational zeros, which we did, and then factor f of x. Well, we already partially have our factors here. We've got the last two from when we had the quadratic. So we've got 3x minus 1, and we've got 2x plus 1. So again, if we want the factors, if we know that 1 is a 0, we know that x minus k is going to be a factor. So k equals 1, x minus k is a factor. That means that x minus 1 has to be a factor. If k is -2, which is our other 0, then that means that x plus 2 is our other factor. So we've got all of our zeros as well as all of our linear factors for the polynomial. Let's go ahead and do it again with this next one over here. So what we can do is start out with our 6x to the third power plus 17x squared minus 31x minus 12. And we'll graph it. And take a look here and say, okay, well, I've got a couple zeros to choose from. Let's go ahead and let's zoom out a little bit. Let's see if I'm missing any. Okay, so I've got, looking here, looks like -4 is a good option. Some small negative number, maybe -1/3, 1/4, something like that, and then something like 1.5. So let's take a look at our possible zeros first to see what our best options will be. So we've got P over Q. Factors of 12 include positive -1, 2, 3, 4, 6, and 12. Factors of 6 include 1, 2, 3, and 6. So starting with the ones, and then matching up with all of the denominators, we have 1, 1/2, 1/3, 1/6. Then we move to 2's. We have 2, that's 1 again, 2/3, 1/3 we already have. Now moving on to 3, 3, 3 over 2, 3 over 3 is 1, 3 over 6 is 1/2, moving on to 4. 4 over 2 is 2, 4/3 is new. 4 over 6 is 2/3, which we already have. Moving on to 6. 6 over 1, 6 over 2 is 3, 6 over 3 is 2, 6 over 6 is 1, and then moving on to 12. 12 over 2 is 6, 12 over 3 is 4, 12 over 6 is 2. We've already got those. So this is our list of possible values. This is a pretty long list of numbers to choose from. That's why we want to use our graph to help narrow down that list. So again, looks like -4 is a good option to choose from. Again, we have that small value in the middle. It doesn't look like it's -1/2, but it's something close to -1/3. So we can always look at -1/3 as an option. Let's see. And then 1.5, which is 3/2. So it looks like 3/2 is also a possible option. So these are the ones that we want to check: -1/3, 3/2, and -4. And we only need one of these to work, because once we do our first synthetic division, we'll have a quadratic, and then we can just solve the quadratic that's left. So let's do -4. That one looks pretty promising. 6, 17, -31, -12. And we get a remainder of 0. So we know that -4 is a 0. And our quotient is 6x squared minus 7x minus 3. We want a product of -18 and a sum of -7. So that's going to be -9 and 2. 6x squared minus 9x plus 2x minus 3. We'll factor out 3x, leaving us with 2x minus 3, and then a 1. So we have 3x plus 1 and 2x minus 3. So there's our two factors, and we can actually go ahead real quick and get our third factor. Since we know that -4 is a 0 and k equals -4, x minus k will be a factor. That means that x plus 4 is our third factor. So we actually have this fully factored already. Now let's go ahead and finish solving to find the other zeros. So 3x plus 1 equals 0, and 2x minus 3 equals 0. So x equals -1/3, and x equals 3/2. So x equals -4, -1/3, and 3/2. And there's all of our zeros. So as you can see, we start by listing all of our possible zeros. We use the graph to figure out which ones we should check, and then we'll use synthetic division in order to factor down to a quadratic. Once we have a quadratic, we can use any of our quadratic methods to either finish factoring or find the rest of our zeros.